Engineering Mathematics 4. The last class we have seen some definition, some ideas in Fourier cosine transform and Fourier sine transform properties, and as well as some problems here. Last two classes here. And today we will continue with some more additional problems in the Fourier sine and cosine transform based on the Fourier sine and cosine transform definitions. Yesterday we have completed two problems here, and today we'll take a third problem. Find the Fourier cosine transform of e power minus a square x square, e power minus a square x square, and hence find the Fourier sine transform of, x e power minus a square x square. X is multiplied here. X e power minus a square x square minus a square x square. They are asking Fourier cosine transform of this function. This is f of x. The solution either given f of x equal to e power minus a square x square, given f of x equal to e power minus a square x square. They are asking Fourier cosine transform of this f of x here. Fourier cosine transform of this f of x, and from the result they are asking Fourier sine transform of x into e power minus a square x square. Here you can use the property. Yes, first find the Fourier cosine transform of f of x equal to e power minus a square x square. Then by definition, Fourier cosine transform of f of x equal to square root of 2 pi pi integral 0 to infinity f of x cos x dx. Square root of 2 pi pi integral 0 to infinity f of x cos x dx. Here instead of f of x here e power minus a square x square, that's equal to root of 2 pi pi f of x equal to e power minus a square x square f of x equal to e power minus a square x square cos x dx. Now if you cannot use the formula, because formula means e power ax cos bx means you can apply easily here, but here square term is present here. Already we have completed this kind of problem in Fourier transform technique. Therefore, if you want to use Fourier transform results here, you have to convert this integral to minus infinity to plus infinity, infinity. Here no problem, you can convert it as a real part of e power isx, e power minus isx here, that you can write here. For e power minus isx you can convert, but here if you have to convert it as a minus infinity to plus infinity. For that you check that whether it is even function or not. Yes, definitely this function is an even function, because x by minus x you can get the same function, therefore it is even function. So if it is an even function, minus infinity to plus infinity can be written as 2 into 0 to infinity. Minus infinity to plus infinity can be 2 into 0 to infinity. Both are same. Therefore 0 to infinity, how can you write 0 to infinity? 1 by 2 of minus infinity to plus infinity. Therefore this 0 to infinity, because of this even function, the 0 to infinity can be written as 1 by 2 of minus infinity to plus infinity e power minus a square x square cos x dx. Minus 1 by 2 of minus infinity plus infinity e power minus a square x square cos x dx. Because of even function here, Right, further root of 2 pi pi 1 by 2 minus infinity plus infinity e power minus a square x square cos x dx. Now minus infinity plus infinity okay, but you have to write this as a e power minus isx form, because if you want to use Fourier transform definition here, yes, that can be written as real part of e power minus isx. Cos x now can be written as real part of e power minus isx. Real part of 1 by root of 2 pi, integral minus infinity plus infinity e power minus a square x square e power minus isx dx. That is equal to real part of now this is totally a Fourier transform definition. Minus infinity plus infinity e power minus isx. This is Fourier transform of e power minus a square x square. Real part of Fourier transform e power minus a square x square. You know the result of this e power minus a square x square under Fourier transform. That will be its transformation is 1 by a root 2, 1 by a root 2 e power minus s square by 4a square. 1 by a root 2 e power minus s square by 4a square. 4a square. Yeah. But here there's no, this is totally real part only, there's no imaginary part here. Totally full thing is a real part. For Fourier cosine transform e power minus a square x square equal to the same thing you can write here 1 by a root 2 e power minus s square by 4a square. E power minus s square by 4a square. That things you can write. Okay, right. This is Fourier cosine transform they are asking here. Deduction is Fourier sine transform of x into e power minus a square x square. X into e power minus a square x. For that you can use the property. Property. Reduction. Put the heading as reduction. Fourier sine transform fs of x into e power minus a square x square. Then e power minus a square x square. You know the property that property in Fourier sine cosine transform. Fs of Fourier sine transform of x into f of x if you require, that is equal to minus d by ds of fc of s. Fourier cosine transform of f of x. This is Fourier cosine transform of f of x. Therefore, fs of x into f of x, that is equal to minus d by ds of fc of s. This is Fourier cosine transform of f of x. Fs of x into e power minus a square x square. Fs of x into e power minus a square x square. Instead of f of x here, e power minus x, instead of x here, therefore we can write as minus d by ds, Fourier cosine transform of this f of x function, e power minus a square, Fourier cosine transform f of x. That is nothing but e power minus a square x square. Fourier cosine transform e power minus a square x square. In the next line, minus d by ds of 1 by a root 2, already identified what is Fourier cosine transform of e power minus a square x square here by a root 2 e power minus s square by 4a square. Minus d by ds of 1 by a root 2 e power minus s square by 4a square. Power minus s square by 4a square. Now differentiate this one with respect to s. 1 by a root 2 as it is, exponential differentiation is exponential e power minus s square by 4a square, and the differentiation of this part with respect to s, minus 2s by 4a square, minus 2s by 4a square. For cancel, what are the things it is possible here? 2 1 by 2 root 2, and here a square a cube here. Therefore, and s is also outside, minus minus plus. For s by a cube 2 root 2, 1 by a cube 2 root 2, s into e power minus s square by 4a square, s into e power minus s square by 4. It will be 1 by a cube 2 root 2, 1 by a cube 2 root 2, s into e power minus s square by 4. For here you are using the property because x is multiplied here. X is multiplied. You can use the property. Is this problem over?
Yes, sir.
Yes. Okay. Take another problem. Find the Fourier sine transform and cosine transform of f of x equal to e power minus ax by x. Find the Fourier sine transform and Fourier cosine transform of f of x equal to e power minus ax by x. F of x is here e power minus ax by x. F of x is e power minus ax by x here. First, any transform you can find here, FST or FCT. FCT, suppose if you find FCT, what is your f of x? F of x is e power minus ax by x. F of x equal to e power minus ax by x. Therefore, by definition, Fourier cosine transform, FCI f of x is equal to f of x equal to root of 2 pi pi root r 2 pi pi integral 0 to infinity f of x cos sx dx, f of x cos sx dx, and the result will be a function of s here, fc of s, fc of s. Yes, instead of f of x here, e power minus ax by x. So fc of e power minus ax by x, e power minus ax by x is equal to root of 2 pi pi, root of 2 pi pi, integral 0 to infinity, integral 0 to infinity, e power minus ax by x, e power minus ax by x, cos sx dx, cos sx dx. Yes, we have to evaluate this integral, but this evaluating this integral is denominator is one x is here, product of three functions: exponential, a reciprocal function or inverse function, and cosine function. A product of three functions. A power minus ax cos sx only means it is no problem. We can usually use a formula definition, and then we can apply that. But you have an extra x in the denominator. If you remove this x, you can get somewhat of easiest way to evaluate the integral. If you want to remove this x here, any x in the denominator, if you want to remove this x, differentiate both sides with respect to s. You don't know this function. This FCF is only we require here. You have to identify what is FCFS, what is Fourier cosine, that's not this one. Therefore, we have to identify FCFS here. But evaluation of this integral is somewhat tedious here. Therefore, we take it as unknown function FCFS. You don't know the result, but assume that this is FC of SK, a function of SK. But your work is that what is FCFS? That is the work you have to identify. You are writing that this is unknown FCFS. Now, we right to left here, that is FCFS. FCFS is equal to root of 2 pi pi integral 0 to infinity, root of 2 pi pi integral 0 to infinity e power minus ax by x cos sx dx, e power minus ax by x cos sx dx. Now, in order to eliminate this x here, you differentiate both sides with respect to s. Differentiate both sides. As result is function of s. So differentiate both sides with respect to s. Okay, differentiate both sides with respect to s. This page over? Is this page over?
Yes, sir.
Okay. Right that differentiate both sides with respect to s. D by dsi FCFS. D by dsi FCFS. Everyone know that if you differentiate with respect to s, it moves inside the integration right side as a partial derivative, Leibniz rule, partial derivative. Therefore, root of 2 pi pi, take it 0 to infinity. Inside integration, it is partial derivative dou by dou s. What are the functions are present inside the integral here? E power minus ax by x cos sx here. So, e power minus ax by x cos sx dx. Okay, right. Now you have to evaluate with respect to, differentiate partially with respect to s. That's no s, here only s. Or if you differentiate this one partially with respect to s here, minus sine sx, minus sine sx. And with respect to s means you can get one additional x here, additional x in the product here, additional x in the product. Therefore, the next line that here root of 2 pi pi integral 0 to infinity e power minus ax by x, same thing. Here cos sx derivative is minus sin sx into x dx. For this x and x get cancelled. X and x get cancelled. For you can get only this part only here. This minus outside here. Minus root of 2 pi pi. Minus root of 2 pi pi. And there will 0 to infinity e power minus ax sin sx dx. Sin sx dx. Now you can evaluate this integral easily. You know the formula e power minus ax by a square plus b square plus a sin bx minus b cos bx. In that manner, I can write minus root of 2 pi pi minus root of 2 pi pi e power minus ax by a square minus a here minus a whole square plus s square minus a square s square plus into a sin minus a sin sx minus a sin sx formula minus, this is formula minus s sin sx, s cos sx, s cos sx, not sin, cos sx, or e power minus ax by minus a square plus s square minus a sin ss minus s cos ss. You know the formula. Limit is 0 to infinity. Limit is 0 to infinity. And applying infinity e power minus infinity 0, and then applying 0 e power 0 1 by s square plus a square sin 0 0 cos 0 1, or minus 1 by s square plus a square into minus s. Now substitute the limits. Substitute the limits. Minus root of 2 pi pi, that is outside, minus root of 2 pi pi here. And then when applying infinity 0, when applying 0 1 by s square plus a square sin 0 0 cos 0 1, but s into cos 0 1 here minus s, right? But left side is d by ds of fcfs, that is very important. Left side is d by ds of fcfs. Left side is d by ds of fcfs. Root minus root of 2 pi pi minus minus plus s by s square plus a square, s by s square plus a square, minus root of 2 pi pi s by s square plus a square. Okay, right. But your work is that you have to identify FCFS. We are in search of FCFS. What is FCFS? We are in search of FCFS. That only gives Fourier cosine transform e power minus ax by x. So we are in search of FCFS, but we obtained only d by ds of FCFS, derivative of FCFS. Therefore, if you want to get FCFS, you have to integrate. Opposite thing you have to do that. Integrate both sides. Integrate both sides with respect to s. Integrate both sides with respect to s. We have, if you integration is inverse part of differentiation, therefore FCFS you can get FCFS that's equal to minus root of 2 pi pi. Integrate with respect to s here. Here is also s and here is also s. Integral s ds by s square plus a square. Integral s ds by s square plus a square. Okay. Right. It's obviously the differentiation of denominator equal to numerator. 2s ds, here s ds. If you want to eliminate that 2, you multiply by 1 by 2. Multiply by 1 by 2. Here 2s ds are coming, it's coming here when you differentiate s square plus a square form. 1 by 2 of integral, because additional 2 are getting here. That will be, this sds can be written differentiation of s square plus a square by s square plus a square. Therefore, this is logarithm of s square plus a square. Logarithm of s square plus. Otherwise, you put substitution here. S square plus a square equal to t. 2s ds equal to t. S ds equal to t by 2. You can get 1 by 2 dt by t, 1 by 2 log t. T is again s square plus a. Any manner you can. Oh, minus root of 2 pi pi 1 by 2. This is because our differentiation of denominator equal to numerator with one more 2 with a multiplication of 2. Therefore, remove the 2 by 1 by 2. Integral differentiation of s square plus a square by s square plus. Your result will be this 2 you can get 1 by root of 2 pi 1 by root of 2 pi with minus sign, logarithm of s square plus a square, logarithm of s square plus a square, plus, because it is indefinite integration here, plus additional constant c, additional constant c. Therefore, this is the result we require here. FCFS only we require, that is Fourier cosine transform of e power minus ax. Fourier cosine transform of e power minus ax by x is equal to minus 1 by root of 2 pi pi logarithm of s square plus a square plus c. Logarithm s square plus a square plus c. Okay, right. In the same manner, can you give the answer for Fourier sine transform? Fourier sine transform of e power minus ax. Can you give the answer here? Fourier sine transform of e power minus ax. All of you try for the same procedure, but for Fourier sine transform definition. Fourier sine. All of you try and give your answer for Fourier sine transform. Try in the same manner, same way, give the answer for Fourier sine transform. What about your answer? Yes, 1 by root of 2 pi minus or plus. Your answer is correct. Minus 1 by root of 2 pi or plus 1 by root of 2. Uh, plus additional constant c you have to put that. Plus additional constant c. For your answer for Fourier sine transform, use the definition of x sin sx dx here e power minus ax by x. Your d by ds fs of s, d by ds fs of s will be root of 2 pi by a by s square plus a square. A by s square plus a square. Okay. After that, you apply integration with respect to s. Integration with respect to s both sides. Then you can get root of 2 pi pi tan inverse s by a. Root of 2 pi pi tan inverse s by a plus c. Tan inverse s by a plus c. I think all of you getting the same answer for this problem. Yes, you see the note here. Note. Suppose they are asking because if I identified Fourier sine or cosine transform e power minus ax by x. Suppose they are asking linear combination of functions here, e power minus ax minus e power minus bx by x here. Right? Then you can use linearity property. Fs are e power minus ax by x. Sine cosine transform both are linear. Minus split that here, e power minus bx by x. Therefore, we can write it as fs of e power minus root of 2 pi pi plus c and plus c get cancelled. You can get minus c get cancelled. Yeah, therefore, you can get it as root of 2 pi pi tan inverse s by a minus tan inverse of s by b. Tan inverse s by a and tan inverse s by b. That type of result you can get there. That type of result you can get there. Okay, right. All of you just note down the note of this part here. Can use linearity. We'll move on to another problem. Fifth one, find f of x. They are asking inverse Fourier transform. Find f of x. If its sine transform is find f of x if its sine transform is e power minus as by s. Find f of s, f of x, not f of s, f of x. If its sine transform is e power minus as by s, e power minus as by s. And also they are asking, hence find the inverse sine transform of 1 by s. Inverse sine transform of 1 by s. They are asking f of x, but sine transform is given here. Sine transform is given. Therefore, sine transform is given fs of s. Sine transform is given fs of s is equal to e power minus as by s. E power minus as by s. They are asking f of x. Therefore, you can use inverse Fourier transform, inverse Fourier sine transform. Then by inverse Fourier sine transform, we have f of x equal to root of 2 pi pi. F of x equal to root of 2 pi pi integral 0 to infinity root of 2 pi pi integral 0 to infinity fs of s sin sx ds. Fs of s sin sx ds. Therefore, f of x equal to root of 2 pi pi. We require f of x. Therefore, there is root of 2 pi pi integral 0 to infinity. Fs of s is equal to e power minus as by s. Power minus as by s. Sin sx ds. Sin sx. Okay. Can anyone give the idea for solving this? After this, how can you solve the integration? Uh, what type of procedure you can follow after to solve this type of integration? Uh, from this, you have to identify f of x. How can you evaluate further? Anyone? No idea why? You see the previous problem and this problem here. Previously, you solved one problem here and this problem. What type of procedure you can follow?
Differentiate with respect to x on both sides.
S is here, therefore cannot easily solve. Therefore, we have to differentiate with respect to x. Result is a function of x here. Therefore, differentiate both sides with respect to x. D by dx f of x. D by dx f of x equal to inside integration. It will move like a dou by dou x. Further, you have to differentiate with respect to x because x in the denominator. Differentiate both sides with respect to x. We have differentiate both sides with respect to x. We have what do you have d by dx f of x. D by dx f of x is equal to root of 2 pi pi root of 2 pi pi integral 0 to infinity root of 2 pi pi integral 0 to infinity dou by dou x of e power minus ax by x sin sx ds. E power minus ax by x sin sx ds. D by dx. Can you proceed further? Give the answer for further lines here. Like a previous problem, you can proceed.
Sorry.
Same answer.
Sir,
Ah.
sir, in first line e power minus as by s.
Oh, A is by. Uh, A is by S. Sorry. A is by S. A is by S. Sorry. What about you differentiate and then integrate? This is e power minus A is by S. Here only S x term is present. X term is present. Hmm. Same answer. Root of 2 pi A by x square plus A square. A by x square plus A square. That is for d by dx of f of x. That is for d by dx of f of x. But we require f of x only. We require f of x. Therefore, f of x means integrate. Integrate root of 2 pi by A outside del dx by x square plus A square. For that, can you can write this 1 by A tan inverse of x by A. 1 by A tan inverse of x by A get cancelled here. A get cancelled. Therefore, that is equal to root of 2 pi tan inverse x by A plus root of 2 pi tan inverse x by A plus, that is your f of x. F of x. For sine transform, you can easily find the value of c. You can easily find the value of c. How here? If you put x equal to 0 here, x equal to 0 here, in this f of x definition, f of x result here, tan inverse of 0 is 0. Or you can get f of x equal to c. The same manner, where is f of x? Here the definition f of x. Here f of x. Here f of x. In this f of x, this is the result we obtained now here. In this f of x also put x equal to 0. Put x equal to 0. Here is also put x equal to 0 here. Sin 0, 0. Totally the integral value equal to 0. For f of x equal to f of 0, 0. F of 0, 0. For apply here, put x equal to 0 in both definition and the above relation here. What about your idea? Initially in the definition f of 0, 0. Here when you put f of 0, you are getting c here. C here. Or you are getting c is equal to c. Therefore, your result is that your f of x equal to root of 2 pi tan inverse x by a. Root of 2 pi tan inverse x by a. If your f of s fs of s Fourier sine transform is e power minus as by s. Fourier sine transform is e power minus as by s. Okay, right. Okay. The deduction, what is the thing they are asking? Find the inverse Fourier sine transform of 1 by s. They are asking find the inverse Fourier sine transform of 1 by s. 1 by s means the same thing here. If you put a equal to 0, you can get 1 by s. When the obtained result, you put a equal to 0. For deduction, put a equal to 0 in the above. Put a equal to 0 in the above result. Then fs of s becomes 1 by s. Fs of s becomes 1 by s. Correspondingly, f of x becomes a equal to 0. Anything by 0, infinity. Root of 2 pi by tan inverse of infinity. Tan inverse of infinity, pi by 2. So your answer will be root of pi by, for fs of s is equal to 1 by s. If your Fourier sine transform is 1 by s, then its function, original function is root of pi by 2. Original function is root of pi by. This is your answer. This is your answer. Okay. Right. All of you understand? Okay? This is the idea. We can. Okay? Right. In the so far obtained relation here, so far obtained relation, so far from the problems, we identified that Fourier cosine transform of e power minus ax. Fourier cosine transform of e power minus ax equal to root of 2 pi pi a by s square plus a square. Similarly, in the first problem we identified like this: e power minus Fourier sine transform of e power minus x is equal to root of 2 pi pi s by s square plus a square. S by s square plus a square. S by s square plus a square. These things you can remember easily. Fourier cosine transform of e power minus ax. Fourier sine transform of e power minus ax is like this. Right. Suppose in the question they are asking that find the inverse Fourier sine transform of s by s square plus a square. S by s square plus a square means, suppose question they are asking means find f of x if fs of s is equal to s by s square plus a square. Fs of s is equal. Then f of x, if you use the definition 1 by root of 2 pi pi, f of x definition under Fourier sine transform is s by s square plus a square sine sx ds. Sine sx ds. That you have to follow. Sine sx ds. Okay. Therefore, you have to evaluate this integral. Evaluating this integral in ordinary way is somewhat tedious. S sine sx denominator is s square plus 3 type of functions here. Denominator is s square plus a square. That is somewhat tedious. Therefore, in that case, if you want to evaluate this one here, again you have to think about assumption. Think about your assumption of f of x. Therefore, you start for this type of problem. We know that you start like this here only. We know that if f of x equal to e power minus ax, then you have to proceed further here. You have to proceed further here. Then with the help of that, you can derive this result. With the help of that, you can derive this result. You can derive s by s square plus a square sine sx ds. Sine sx. Already we have solved this problem yesterday. I think yesterday or day before yesterday class only. Yesterday class we solved that this condition. Inversion formula. Integral 0 to infinity s by s square plus a square sine sx dx. Integral 0 to infinity s by s square plus a square sine sx dx equal to pi by 2 e power minus x. Pi by 2 e power. For the same thing, therefore if you apply Fourier sine transform, if you want to get f of x and from this result here, 0 to infinity s by s square plus a square sine sx ds at one stage, you are need of this relation here. For that relation can also be replaced by pi by 2, or otherwise you can directly write that. The relation. We know that if f of x equal to e power minus ax, then its Fourier sine transform is this one. Fourier sine transform that contain s by s square plus a square. From this, if you need inverse means root of pi by 2. Root of pi by 2. So this integral already by yesterday's idea, we can write that pi by 2 e power minus ax. This is pi by 2 e power minus ax, this integral. So it will be root of pi by 2 e power minus ax. Your answer is. Or any manner you can proceed. Or if you want to evaluate from this fs of s, we require f of x means you cross multiply this one. Cross multiply this one. Root of pi by 2 e power minus ax. Root of pi by 2 e power minus ax. So these two are very standard results. These two are very standard results. You have to remember always. You have to remember always. Similarly, the reverse thing is also possible. Reverse thing also possible. Suppose your reverse function is 1 by x square plus a square. X square plus, suppose your f of x is 1 by x square plus a square. Okay. Suppose your f of x is 1 by x square plus a square. That type of function here. Obviously, your what about your Fourier sine or cosine transform? Fourier sine or cosine transform. What about your idea? This e power minus s comes here. This e power minus as comes here. Correct or not? For your you can reverse these two. Fourier cosine transform e power minus ax equal to this one. Similarly, Fourier inverse of this one is this one here. Or any manner you can transform here. Any manner you can transform here. Correspondingly, if you change the function as 1 by x square plus a square, your transform will be e power minus as form with a constant multiplier. With a constant multiplier here. Or in that case, pi by 2 e power minus as, that type of result you can get that. Therefore, if you remember these two results, then it is very easy to identify. Suppose they are asking some unsolvable integration, you can get that like that. The denominator is square plus a square, that type of results you can get there. You can easily get the idea. You can easily get the idea. Suppose the question may be like this: solve the integral equation. Integral 0 to infinity f of x cos sx dx equal to s for 0 less than s less than 1, 0 for s greater than 1, s greater than 1. They are asking solve this integral equation. Solve this integral equation. That value is like this: s 0 less than s less than 1, 0 for s greater than 1, 0 for s greater than 1. What type of idea here? This is like a 0 to infinity. Therefore, cosine or sine transform. Here cosine is percent. Therefore, cosine transform. Or the given relation, if you multiply root of 2 pi pi, okay, root of 2 pi pi, that is nothing but what? Fourier sine transform. Fourier cosine transform. In the given relation, root of 2 pi pi, interval 0 to infinity, f of x cos sx dx equal to, you can write as root of 2 pi pi here, s into root of 2 pi pi, 0 less than s less than 1, 0 for x greater than 1, 0 less than x less than 1. What is this? This is fs of, sorry, fc of s, Fourier cosine transform. Now Fourier cosine transform given as s root of 2 pi 0 less than s less than 1 and 0 for s greater than 1. Solve this integral equation means you have to identify unknown. You have to identify the unknown. Unknown. That is solve means you have to identify unknown. time at what time it disconnected? 5 or 10 minutes, 5 minutes before,
5 minutes before, sir.
5 minutes before.
Yes, sir.
Uh, this problem noted. This integral, solve the integral equation.
Sir, are you presenting, sir?
Oh, sorry. This problem noted down, integral equation.
Yes, sir.
Okay. But the solution completed, solution.
No, sir.
No, okay. But anyway, you know the idea, na? Idea. Question only noted, Question only.
Yes, sir.
Okay. All the remaining people, present are present. Okay. And the 0 to infinity f of x means it is like a Fourier cosine transform definition. If you multiply by root of 2 pi pi, root of 2 pi pi, raise into square root of 2 pi pi, 0 less than s less than 1, s greater than 1. But it is Fourier cosine transform definition here, FC of s. If you want to solve the integral equation means you have to identify f of x. That relation is given. From that relation, solve means you have to identify unknown. Unknown is here f of x. So from this, the given relation is like a FC of s. From this unknown, if you want to find f of x means you have to use Fourier cosine transform, inverse Fourier cosine transform. So to find f of x by inverse Fourier cosine transform, we can use root of 2 pi by 0 to 1, 0 to infinity, FC of s cos s x means. Root of 2 pi pi, based on the given relation 0 to 1 defined and s greater than 1, 0. So 0 to 1, 1 to infinity, FC of s cos s x ds. Root of 2 pi pi, 0 to 1, FC of s is root of 2 pi pi s, root of 2 pi pi s cos s x for 0 to 1. You see that root of 2 pi pi s. For other things 0, 0. For 2 pi pi root of 2 pi pi, 2 pi pi, you can write s into cos s x ds, 0 to 1. Apply Bernoulli's formula, UV model. But with respect to s, that is very important with respect to s. Bernoulli's formula, s u v1 with respect to s over sin sx by x. With respect to s, you have to proceed minus formula minus differentiation of this one with respect to s 1, integration of this one with respect to s minus cos s x by x square, 0 to 1. For 2 pi pi 1 by x, limit is for s here. So you take x outside, is also x outside here, 0 to 1, 0 to 1. When apply 1 here, 1 into sin x, sin s is 1, s is 0, s is 1 cos x, s 0 cos 0 1. I will take 1 by x square commonly. This will be your f of x, required f of x. 2 by x square by pi, 2 by 2 divided by x square pi, cos x plus x sin x minus 1. Noted down? Ah?
Yes, sir.
Okay. Thank you. Okay. That's all the session, and we will see some more additional problems in the next class. Thank you. Thank you for attending.
Thank you, sir.
Thank you.